Today we're going to be talking about some attributes and transformations of square root functions. And so you guys have already worked with this at the very beginning of the year when we did parent functions and we worked on translating and transforming them. And so you are familiar, this should ring a bell with you. You should be familiar with it, but we're just going to do a brief review so that you have that fresh on your brain for when we do square root functions, because this is going to come in handy with helping us with domain and range. So remember, if you'll recall, at the very beginning of the year, we talked about what A, what B, what H, and what K all represent. A is going to be vertically stretching or compressing. Okay, so the number that, if you see a number outside here, or if you see a negative, you're vertically stretching or compressing, and then you're also reflecting across the x-axis. The B value is going to be a horizontal stretch or compress. Okay, and I'm going to mark this out because that is not accurate as far as when we're trying to describe our transformation. So horizontal stretch or compress by a factor of B. And then we've got a horizontal translation. So across, this is going to be, H is going to be when you are moving left or right. And remember, left is going to be when we have a positive, right is going to be when we have a negative. It's opposite of what you would think. And then our K value is a vertical translation, up or down. And so if it's positive, we are moving up. If it's negative, we are moving down. And so just remember that that's kind of what each of those represent. So as we go through and it's asking you to explain the transformations, you're aware of what the A, the B, the H, and the K all do. Now, example 1, that's exactly what they're asking us to do. They are giving us a function and they are asking us to explain the transformation from the parent, which is y equals the square root of x. So let's look at each individual piece and we're going to describe what's happening with each part. Now notice, first thing I'm going to do is take care of what's outside of our square root. So I have a negative and I have a 2. That means that there are two things going on here. The first thing is that I have a reflection over the x-axis. The second thing, if you'll go back and remember, the A value is a vertical stretch. So I'm going to write that I have a vertical stretch by a factor of 2. Not negative 2, because the negative was taken care of by reflecting it over the x-axis. So I have a vertical stretch by a factor of 2. The third thing I have going on is that minus 7 underneath the square root. So that minus 7 means that I am translating, and be sure you use the math words, not moving it over 7 units to the left. That's not really, or to the right. That's not really telling me much. You need to make sure you use the math terminology. So translating 7 units to the right. And then finally, the fourth thing that we have is this plus 4. And that is going to be, you can say translating 4 units up. So make sure that you break it apart and cover each individual thing. You know, count it up before you start. Okay, how many things am I doing to this parent function? And in this case, we had 4 different things that we were doing. Now we're going to do part B, and if you notice, we have only two things. We have that 3 underneath, and we have the -2. So I'm going to write, first things first is I have a horizontal stretch by a factor of 3. And then that -2 means that I'm translating 2 units down. And that takes care of explaining our transformations. Hopefully you can kind of recall when we did that at the beginning of the year. Now what they're asking us to do is they're giving us a description and asking us to produce the function. So we're going to be writing, so I'm going to go ahead and you can write f of x or you can write y equals. Now, our parent function is the square root of x. Now, what they're telling me is that they're horizontally compressing it by a factor of 3. So go back up if you can't remember. The horizontal is the underneath. Notice it's the b value. So it's going to go underneath our square root. Okay, so I am going to have a 3 under here with my x. And then I am translating it 4 units up. So let me go ahead and erase part of that so it doesn't look like that's included. And that's one thing you need to be very careful about, is don't draw your square root all the way across like that, because that shows me that you're telling me that's underneath. And then finally we are reflecting it over the x-axis. So I didn't leave enough room to put a minus sign, so I'm just going to recopy it. So f of x equals negative square root of 3x plus 4. And that is my solution. Now what we're going to do is work a little bit with domain and range and find the domain and the range for each of the square root functions. And so I'm going to go ahead and write domain and range. Now, remember, domain are the x values. So if you were to plug this into the calculator, first off, just based on what we know about shifting and what we just talked about transformations, I know that I am moving this 3 units to the right, and I know that I'm also moving it 2 units up. So if you're looking at your graph, this is what it would look like, roughly. So think about what that does for your domain. Now remember, we always, for domain, you want to set your, whatever's underneath your square root, set it equal to 0. Because that's going to give you the value that gives you 0, and then you can have everything above that so that you don't take the square root of a negative number. So my domain here, and you can kind of verify that with a graph, is everything over the value of 3. We can have 3, so we're going to use a bracket instead of a parenthesis, and that's going to be my domain. Now, as far as range goes, if you look, you're looking at the y values, and so right here is where we start having y values, and then we have everything above that. So as far as my range goes, I have everything from 2 and up. And that's how you're going to determine your domain and range. You can use that transformation knowledge that you have. You can use that to help you determine the domain and the range. So if you look here, I know my domain is going to be based off of what I set what's underneath the square root, what I set equal to 0. So I'm going to come over here, I'm going to go ahead and set that equal to 0, and I'm going to solve. Plus 3, 2x equals 3. Divide out the 2, x equals 3/2. So what this is telling me, and again on the graph, I'm going to have everything 3/2 is the same as 1.5. So right here, this is what it would look like. I shifted it over 3/2 and I shifted it down 4 units. And so that's kind of what my square root function is going to look like, roughly. So I know as far as my domain goes, I've got everything from 3/2 to positive infinity. That's my domain. And then for my range, I know that I've got everything from -4 to infinity, based off of my y values start here and go up. And that's going to be my range. So you can use those transformation thoughts and knowledge to help you figure domain and range. Now, this is one other thing that we're going to use. It's going to give us y-intercepts or x-intercepts and ask us to produce a square root function that satisfies that. So if I come over here and just draw a rough sketch, and I know that I've got a y-intercept of -2. So roughly that's what it would look like. You could write an equation based off of that. So first off, if I know that my y-intercept is -2, that means that I have shifted it down 2 units. Now think about, if we're shifting it down 2 units, where does that fall? And that is going to fall outside of the square root. And there you have it. Now you could go in and you could put other numbers in, or you could, flip it, or whatever you want to do. You can change. It doesn't have to be that basic function, but that's just what I'm going to do because that's the easiest for me to see. So then again, if I have my x-intercept, so x-intercept's where it crosses the x-axis. So if I have it at 1, then it would look something like that. Which means, think about translating. I have translated it 1 unit to the right. And so my translating to the right is going to be underneath my square root. And so here they're just trying to help you realize, based off of the x-intercept and the y-intercept, kind of how you could write an equation for a square root function. All right, now example 5. It says give the minimum and the maximum values of the specified interval. So I've given you a square root function and I have given you the interval of 2 to 10 to look at. So you could do this a couple of ways. You could plug this into your calculator into y equals. So in a y equals, plug that in exactly as you see it, and you can go to your table and you can look at the values that go between 2 and 10. You can also do it by hand. So you can look at the picture of the graph. I know roughly, that my graph is, first off, it's upside down, flipped over and shifted over 2 units. So this is kind of what it's going to look like. So if that's what your graph is going to look like, then think about your maximum value is that value. And then you're going to go 10, because it's going to keep going down. I didn't draw a very accurate graph the first time. Let me erase that. So it's going to continue to go down. So when you hit 10, so let's say that's 10, that's going to be your minimum value. So you can graph it out on your calculator. You can go to your table and you can actually pick out the values that are the highest and the lowest between 2 and 10. You can also do that algebraically. So I have gone and I've looked and I know that 2 is going to be my maximum value. So let me come over here and write max. I know that when I plug in f of 2, -2 minus 2, that's going to give me 0. So my maximum value is at 0, which you can tell that by looking right here at the graph. And then I know that my minimum value is going to be when I plug in 10. And so I've got negative square root of 10 minus 2. That's going to give me negative square root of 8. You can get your calculator, you can type that in. You could leave it negative square root of 8 if you would like. But when you plug in negative square root of 8, you get about negative 2.83. And so you can also write it like that. And that's all it's wanting. It's just wanting you to isolate a certain interval, pick out the highest number, the maximum, pick out the lowest number, the minimum, and give those values. Okay, and last example is just graphing. So again, the easiest way to do this would be to go ahead and plug in your function into y equals, and go ahead and graph that out. So 2 square root of negative x plus 1. The best way to get values would be to go to your table so that you can get exact values. And I would make sure that you pick values that are like whole numbers. So skip over the decimals. I've got 1, 0, 0, 2. Let's find one more. Negative 3, 4. And go ahead and plot those on your graph. So 1, 0, 0, 2, and negative 3, 4. And so your graph is going to look something like that. We have moved it 1 unit to the right. We have vertically stretched it by a factor of 2, and we've also reflected it over the y-axis. Now, the last thing it's asking for are the x and the y-intercepts. So, as far as x-intercepts, where does it cross the x-axis? It crosses the x-axis at 1, 0. And my y-intercept, so where does it cross the y-axis? 0, 2. So make sure that when you're graphing these and it asks for the x and y-intercept that you give it. Don't just graph it and call it good. Make sure you answer the full question. And that takes care of our attributes and transformations of square roots.